say when you look at colleges, they will say 50% of all the kids that go to our college have this GPA of this. And then they'll say 25% have a GPA lower than this and 25% have a higher one. So they will generally talk about it's a box and whiskers plot. They will talk about the middle 50%. And I mean, I'm not going to lie to you and tell you it's low. It's pretty high for most colleges.
Depending on the college, you mean?
Depending upon the college. I mean, there's literally some colleges that won't even ask that, but I'm saying the colleges that you five are probably going to be applying to, then they're going to have a number that it's probably something you need to pay attention to. So keeping your GPA high, because the second statement that I'll usually get for some kids, which is this kind of leads into semester finals. And in semester finals, literally some kids that are on the ball will do that calculation. They'll already know what they have. That's why you look at your syllabus. And it says, you know, the semester final is worth 10% of your grade. And then they'll do something, they'll say, well, I have a 96 right now.
Semester final, 10%?
No, I'm just throwing that number out.
I was going to say, I'm not going to try at all. I don't need to try. 10%.
So they'll say, you know, I got a 96, and with that 10% added in, then I could literally get a C and still wind up with an A. And so a lot of kids will do that calculation. And I'm not saying that that is a bad thing. I'm saying a better thing would be to just always study for your test and do as well as you can. There's a difference between burying yourself in studying and, you know, putting together a good amount of work to get a decent grade. All right, any questions on the homework?
It was homework.
Oh, I do.
And it was all system of equations, basically, other than the first two. Yeah.
I have a question on the quiz.
And I believe the last statement I said to you was, come see me.
Yeah, I wasn't there during student advisement.
I know you weren't. All right. Calendar is all updated now. Field day is now on Friday, unless they want to change it for the 14th time.
Oh, I don't like that bottom row.
Yeah, I don't like that either.
What's
I
the
have it on the
I do have the actual class periods where.
We already know.
Yeah.
Okay, cool. Just remember the schedule is you show up, you go to student advisement for 45-ish to an hour. I forget how long it is. That's the study for your first test. You go take hour and a half per semester final. And in between the two tests, there's another hour or so of student advisement. Maybe it's only 45 minutes. This is going to be a new thing because we didn't have lockers last year and we didn't really, you had all your books. Well, now we have to have you clear out your lockers. So you're going to come in, you're going to take, what do you have for fifth period?
History.
You take your history, you're going to go to student advisement. They're going to have like a checklist for you to follow. Clean out your lockers, put your books here. You got to turn in your books type thing. Fill out a piece of paper that's, you know, it's probably going to, you're putting little check marks on what you just did. Do you owe any fees, that sort of thing, yada, yada, yada. Normal checkout procedures. And then that should be it. If you're absent one of the days, you're coming in on Friday and see a lot of see a lot of unpleasant or unhappy teachers because you were absent one of the days. We have to give you a semester final on Friday. If it's like really like you were sick and you missed like a day or even, God forbid, two.
What if you missed the whole week?
Yeah, what if you missed
We're going to have some private talks, right? Like we can't give you 7 tests on one day. That's ridiculous, right? But usually what happens is somebody has like an orthodontist meeting or something like that. And they're taking one final.
COVID?
Yeah, what?
You get COVID, I assume it's all going to be online. So.
Oh, that
What
doesn't seem
if
safe.
someone gets COVID on the first day we go on the quarantine?
Well, it's what we did last year. We took semester finals
I
last
feel
year.
like there's gonna be at least one person who's like, semester final online.
I'm feeling sick. Yeah, that might happen.
I think they're going to allow that.
All right.
Oh my God.
Homework.
That's
If you've already got it, if
Wait,
you already
that's-
started
that's
on it, I'm going to change the instructions. There are 24 problems I want you to do. The first 10, I only want the answer in slope-intercept form.
So you mean like
Wh-
like
Y equals mx plus b.
Okay.
The second 7 or so right there, I want in point slope form, which is a new form. We've talked about
Y
it.
minus
Maybe.
y1 equals m times x minus x1.
Correct.
And parentheses. There's parentheses are an x minus
Oh,
x1.
yeah, there's
Well,
parentheses.
yeah, that's what I meant.
I thought he said quantity. You didn't say quantity?
No, you didn't say quantity.
Okay. And then the last one, I don't care, whichever one you like.
17.
I like cheese.
I like 17.
but I
No,
can't eat 'em.
whichever one you want.
No,
Slope,
no, I
intercept,
like
or point slope.
17.
Okay.
Of course better.
I forget what the instructions, why I wanted to change it. Maybe it had to do with both, but I forget what. But those are the instructions.
What if nuclear winter starts happening and we can't escape?
Well, the first thing you have to have is a nuclear explosion before a nuclear winter.
Yeah,
What if
McKinley.
someone buried a bunch of nukes in the center of the earth and then they just went off one day?
There wouldn't be nuclear winter. Nuclear winter is because it happens above ground, and it kicks up so much dust into the atmosphere that it blocks out the sun.
Okay.
It permafrosts over all living environments, and then everything's just winter.
And whose bright idea was to make that?
And this has happened in the past as well too. In the 1800s, I think it's the 1800s. There was a famous volcano called Krakatoa, and when Krakatoa, I believe, is in Indonesia. When Krakatoa, or maybe it's Malaysia. When Krakatoa went off, it was called the summer or the year without summer, because it literally a blanket of ash covered the atmosphere and causes the temperatures to plummet, and summer was more like winter. All right, here we go. This is somewhat new. There's a couple techniques here I'll have to show you, but it's not so strange from stuff that we've done before. So linear equations are what we've been messing with. These are equations that make lines. There's one right there. It makes that line right there. We have three forms for linear equations. The first one was called standard form. That's where the x and the y are on one side. A and B are both not zero. One of them can be zero. C can always be zero. There's an example right there. We have slope-intercept form, and that's kind of everything that we've done so far. Turns out there's one more form. We've learned it today, and it's called point-slope form. We've taken these, and up to now we've graphed. Remember, if it's in standard form, graph the intercepts. Let x be 0, solve for y. Let y be 0. That's the quickest way. When it's in slope-intercept form, plug in the y-intercept and apply the slope to that. Lastly, I guess, if you really wanted to make your life painful, you could do a table of values as well, too, always. All right, so today we're going to learn the third form. So the first thing we're going to do is we're going to go back to slope-intercept form, and this is ridiculously easy. So McKinley, I'm going to tell you the slope is -5/3 and the y-intercept is 4. Could you tell me the equation of that line in slope-intercept form?
Yes,
What's the equation of that line?
it is
7.
7.
And I'll give you a hint.
Yeah,
It needs to be in this form.
yeah, I'm thinking that one. So it just needs to be
You're using the
-5
example from
over
the book.
3.
I know, you read it from left to right.
Yeah, that's negative. Y equals -5 over 3x plus 4.
And literally, this is the first 6 questions, 5 questions for
Yeah,
homework.
it's 6. It's 6.
First 6 questions for homework.
Okay.
Do I need to insult your intelligence with more of these?
Oh, this
Yes.
is all, 1 through 10 to be so easy.
Yeah, 1 through 10.
Not 7
Well,
through 10.
not
but-
just 7 through 10, but we'll get that one's. It's not too bad.
Intercept, and you can just figure that out.
All right, the only one I want to point
I
out
know.
is the very last one right here then. So the very last one, Ben, what's the equation?
Well, all it is just 3 over 4x. There's no
Left to right.
Oh, y equals 3 over 4x plus 0.
Do you need to add the 0?
No.
You don't. So all of these, the 1 through 6, these are ridiculously easy, okay? They do come in a bit more challenging. I say hard, but this was more maybe medium. We'll see. All right, I'm going to give you the 2 intercepts. That's it.
Huh?
I need you to write that in slope-intercept form.
Okay.
I guess you
Y equals
Yeah, that's a
y
problem.
equals 1/2 plus 3.
6 over 3.
1/2 x plus 3. No, 6 over 3. No.
So how are you getting those
He's
numbers?
He's correct.
How are you getting those
I'm
numbers?
doing rise over run. The y is the run.
Well, how do you know what the rise is and what the run is?
And the
It's
y
the
has
x
to
and
be
y.
the x, y, and the y has to be
You got to
negative.
explain that a little bit better.
So the y has to be negative because here, wait. If you imagine it's 1 and 1, you're going this way and then you're going down. So then this is the y, which is 1, and then the x is 1 too. But you're going down, so then the y is always negative. And if you were to graph that, you could say -6, and you can go over 6, and you can go down 3, and then you'd have -3 over 6, which is -1/2, negative
I like
1/2.
Be careful. I would try not to do the whole thing in your head. Right? I'm going to give you an alternate explanation. So what he's basically saying is, think about it in your head. if it's an x-intercept, it's going to be somewhere over here. And we're told it's way over here at -6, right? And we're told the y-intercept is 3. And we know between any 2 points, the line doesn't, the slope of the line never changes. So he's just saying, well, how do you get from here to here? That's the slope, and that's the y-intercept. So the slope must be
Up 3.
up 3,
Over
right 6. That would be 3/6, which is a half. Now he did that in his head. Obviously, he can do that one, right? But just be careful. I'm going to give you an alternate way of doing it.
Not really that hard.
That's not that hard. I might draw that out just so I don't make a silly mistake. Because if it happened to be -1/2 or something like that, you wouldn't want to make that silly mistake. The alternate method is, well, basically, if this is the y-intercept, all we need to do is calculate slope. So how many points do we need to calculate slope? 2. Well, there's 2 points right here. One is an x-intercept, one is a y-intercept. We know that for an x, if you live on the x-axis, that's the x-intercept, then you must be of the form that number comma 0. I mean, if you're on the x-axis, your y value is always 0. Conversely, if you live on the y-axis, your x value is 0. So all we do is we throw these 2 points in where it says A and B. We got 2 points. Now, this is what he just did. It's just he was doing it more in a visual sense. This is more of a calculation one. It's still going to be 3 minus 0, 0 minus -6, and well, that's still half. There's a mistake here. I forgot to change it from period 2 when I noticed the mistake. Okay. There's the slope 1/2, the y-intercept, that's your B. Now it's just like question 1 through 6, where they give you the slope and the y-intercept. So y equals 1/2 x plus 3. Stop me if I went too fast on that. Not on this slide, but next one I think is the mistake. Okay. Let's do this a couple times. All right. Do you want to do it in your head, or you want to do it with the 2 points?
Head.
Well, if you're doing it in your head, you got to think of this. This is, like I said, you can get into problems if you don't have a solid idea. It says the x-intercept is +2, and the y-intercept is -2.
Here we go.
Hold it up. It's 1.
1.
It's 1.
1
Okay.
minus
It's just you
1
can
x,
just
x minus 2.
subtract it. You should just do -2 minus 2.
Will that always work? Well, let's
Not
see.
that.
Well, let's see the other possibilities.
It
So
would be 2 minus negative. No.
if the slope was -2 and the y-intercept was -2, we know that slope is -1. Does that work?
Yeah.
So what's the technique?
You can just do y over x, and x is always negative.
Is it always?
Yeah, because then you have -2, which is positive, and then positive.
Because there must be some, and it's because there's that subtraction involved.
Right. So it's just x is always negative, and you could do y over x.
Or y is always negative.
Either one.
Okay. Just be careful. All
I
right.
mean,
I'm going to choose to teach this by throwing the 2 points. So if you throw the 2 points, the x is always the number, comma 0, and the y is always 0, comma the number. So when we throw in those 2 points into the slope formula, -2 minus 0. Is this the where my mistake is? Nope. And then 0 minus 2. Jack's saying, well, it's always rise over run, and then you got to make one of them negative, right? Just be careful with that. Oh, by the way, that's not the final answer. That's just the slope. There's the y-intercept of -2, so y equals x minus 2, and you're done. These get really small because I want to do 3 of them on a page. All right, McKinley, can you do this one?
Yeah, I can do that one. So 0 x comma -3 and not at x at y x.
Yes.
Yeah, x over 9 0. Wait,
You're saying words I'm not following you.
I'm trying my best to word this, but just do.
What's the y-intercept as a point?
It's 0 negative x. Sorry, 0 9.
0, 9. Okay. Now we just simply do the slope formula.
Yeah.
So
9 minus 0
over.
-3 mines 0.
You flipped them around.
0 minus.
You said 9 minus 0, same pattern. Then it'll be 0 minus -3. Okay.
And then you get -9 over 3.
Yeah, there's my mistake right there. It's +9.
Yeah.
I knew I had a mistake there
Yeah, it
somewhere.
would be part of that. It would be,
That's sick.
So it would just be 3.
3, yeah, 3.
And I didn't make a mistake there, but, okay, that's your slope, that's your y-intercept, so the equation would be,
3x minus 9. 9 minus 3x. 9x, y equals 3x minus 9. Yeah, that's the answer.
Yeah, y equals 3x plus 9.
No, it's not plus 9, it'd be negative.
there isn't a negative in the formula, it's positive, so it's plus 9.
Only negative if you're calculating slope.
And there's a couple other ones as well, too. We'll see them as well. Andy, want to do the last one?
Sure. So it'd be -2 minus 0 to -2 over 0 minus -6.
2 negatives make a positive. So it's -2 over, which is,
Negative
therefore, the equation will be,
y equals -1 over 3x minus 2.
if I don't make this change right now, this mistake will appear next year, and I'll wonder again why I made that mistake. Okay, very good.
The new class won't be, the new victim.
Well, the problem is that my non-honors one, I got to make that change in their class as well, too.
Non-eyes.
Okay. Don't forget vertical and horizontal lines. Who's got their book of truth open? All vertical lines are of the form.
0.
No,
No.
all vertical lines are of the form.
Y equals K.
Wouldn't you like to say that? Because doesn't
I
it
thought you said horizontal. Vertical
doesn't it
is-
make sense that
vertical is
vertical
X
lines would say
equals- vertical is X
y?
equals K. I know what you're talking
Doesn't. It's the opposite. All vertical lines are the form of x equals the number, and all horizontal are y equals k. So when we write equations, vertical lines, be careful. What does it say here? What's it say? Somebody? So which line, vertical or horizontal, is the slope not defined?
Vertical.
Okay. Remember, vertical, because if you calculated the slope, you'd have no run, but you would have rise. So you would get a fraction where the denominator would be 0 because it has no run. Therefore, we say it has no slope. So this is how you tell. Now, tonight for homework, it's not going to say, hey, it's a vertical line. It's going to say the slope is undefined and the infinity is not a number, and the x-intercept is 4. You're gonna have to remember that means vertical. Therefore, it's an x equals k. The number's 4.
You know, it's also not a number 2I, and yet we use that.
Well, no, that is a number. So
No, it's an imaginary
infinity, yeah, but there's a big distinction here.
number.
Infinity is a concept, not a number, where imaginary numbers are literally a number. It's called a complex number, not a real number, but it is a complex number. And you can do add, subtract, multiply, and divide with it. You don't do add, subtract, multiply, and divide with infinity. Like you don't say infinity plus infinity is to infinity.
It would be.
No, it would just be infinity.
It's just infinity, right?
But technically, 2 times infinity
When,
is infinity.
when you
so-
take higher level calculus, you get into this idea of what happens when infinity is an answer to something, and I'll let you enjoy that when you get to calculus. I don't think we talk about infinity a little bit more in pre-calculus. We don't really do too much of it. All right, horizontal lines are the other ones. You really want to say it's equal to x equals because the x-axis is horizontal, but it's y equals. Okay, the way you'll know it's a horizontal line is the slope will be 0. This is key to know that vertical lines have undefined slope, and horizontal line the slope is 0. Okay, in both cases you have a nice neat formula. Technically, the horizontal line is still in slope-intercept form. Vertical line is not in slope-intercept form, because if we were to write this one right here, y equals -2, as y equals 0x minus 2, well, that's in slope-intercept form. Okay. Of these 3, one of them is challenging, 2 are easy. Which one is which?
The challenging one is the one that's
The bottom.
undefined.
Why is the bottom one challenging?
Because it's undefined.
What is undefined?
The y
The
intercept.
why?
Now you got to put your thinking. Well, let's do the top. Vertical or horizontal?
So it's vertical.
Vertical. It's the first
So
one.
So the
Minus
x-intercept
of
is,
3.
so it's, no, it's
First one, vertical or horizontal?
horizontal.
Okay, so y equals 3. Second one, vertical or horizontal?
Horizontal.
Y vertical.
Because that's not a 0, that's an undefined symbol.
But it's on the x-intercept.
Says the x-intercept is undefined. So that
So
means
it's-
it doesn't go through the x. That makes it horizontal. See what I mean?
On the
They're
Y.
trying to trick you. Notice the first one says the way we would like it, slope and intercept. There's no slope in these last two. It turns out that the middle two are hard. You got to think them through. So this says the x-intercept, there is no x, that's undefined, means there isn't one. Okay, well, what line doesn't go through the x-axis unless it's the x-axis itself is a horizontal line. Horizontal lines are the form of y equals. So the second one is also, let me catch up, is also y equals 9. The last one, vertical or horizontal?
Vertical.
Y vertical,
Because there's no y-intercept.
unless it's the, no,
Unless it is the
unless it's the y-axis. So,
if x
but
was
then this would be 0.
0, right, so it isn't.
Right.
the y-axis.
And that's a classic math teacher problem. Y-intercept of undefined, x-intercept of 0, vertical line of the x-axis, y-axis, sorry. So x equals -6. So one easy one, two challenging ones. Okay, cool. All right, here comes the new stuff. Ready? All right. Here's the setup. We know a slope and we know a point. That's it. What's the equation of the line? We know a slope and we know a point. What's the equation of the line? We got to prove it.
Oh, well, darn you.
Oh, well, then you can just.
I know a
subtract-
slope. I'm going to suspiciously claim that the slope is m and the point that I know is x1, y1.
I know it.
That's my start.
Well,
So you
yeah.
can say that because you can subtract y, and then you already get the y minus y1, the y-intercept. You can
Why are you
subtract the y-
subtracting?
Because
y?
you're doing a slope-intercept form.
Yeah, but how do you get that from that?
Because
You're not
you
told that that's the y-intercept.
just use y equals mx plus b.
Yeah, but you're not told that that's the y-intercept.
Yeah, but y1 x1 could be the y1.
It could be.
It could be 0, 1.
It could be.
So then use that.
You know, but we don't know if it even goes through 0, though.
It does. Well, it. I
At
mean,
some point it does. We just don't know what the other part of it is.
Right. So you said it doesn't go to 0.
Well, I'm saying it could.
It does.
It goes through a 0. Just we can't say anything beyond. We could say 0, comma b. That would be true.
Yeah, 0, comma b. Let's use
Mhm.
that then. But then you would have, so if you were to prove it, you don't really.
Yeah, but then how are we going to calculate the slope?
You already have slope m. Just use m times x, and then you could say that x minus x1 equals x. Because if you're using 0b, then x minus 0 equals x.
I'm going to take a different tack. This chapter is called coordinate geometry, and every proof that we do, we basically take what we're given and we put it on the coordinate plane. So I'm going to take what I've been given and put it on the coordinate plane. So I'm given a slope. I'm given that there's a line. I'm given its slope and a point. Now, be careful with this. When I throw on the coordinate plane, it's going to look like I throw it somewhere specific. I'm not going to claim it's somewhere specific. I'm just going to basically draw it. Now, clearly, I'm claiming the slope is positive. I don't know that for sure. Right? I'm also not going to claim that this picture is the line. I'm saying it's one of an infinite possibilities of lines. Okay. The one thing I will say, and it should say somewhere, it's not a vertical line. It should say this is a non-vertical line. Okay. So I got a non-vertical line with the slope of m. Well, that's why it's non-vertical, because it has a slope. And I have a point. In red is what we're given. Generally speaking, 2 points define a line. So somewhere on this line, there's another point. I don't know where it is, but I'm going to claim it's xy. That's my setup. Now, Jack, you can take over. Now what?
Now, after we do that, we can calculate the slope of
We could. We calculate the slope. So how would I calculate the slope?
is x minus x1 equals.
Well, we would need
over-
0.2.
No, y over y1.
Suspiciously, since I claim this is 0.1, that makes the other point somewhere on the line. We don't know where it is.
2.
Makes that 0.2. So if we plug that into the slope formula, what do we get?
Plug that, we get y2 minus y1.
We're just going to call it xy.
Okay, y minus y1 over x minus x1.
Okay. So I'm just plugging that into there. So we know that this is my 0.2. You're like, why don't you call it x? You'll see why. We plug that into that, and I get that, and we are, by definition, this is the slope right here. And we're going to say that that equals m because that's the definition of slope. Change in y over the change in x.
Oh, I know what you're gonna, okay, then you can multiply that, and then you can get 1 minus y1 equals m times x.
What are we
minus-
multiplying by?
You're multiplying both sides by x minus x1.
Who likes fractions, right?
Me.
One person. The rest of us don't like fraction. Let's clear the fraction. Remember doing that last year? You can always, as long as it's an equation, you can always get rid of the fraction by multiplying by the denominator. The denominator is x minus x1. So I'm going to multiply both sides, because I don't like fractions, by x minus x1. As long as you do it to both sides, we're good to go.
And then you get.
What
point
happens
slope
on the
form.
left side?
You get point slope form.
What happens on the left
You
side?
get point slope form.
No,
They cancel.
they cancel. Thank you.
Ah,
And then what we're left with, this big ugly mess right here,
point slope form.
is finally where we're headed. Well, what did we do? We did a whole lot of nothing with no numbers, just variables. Yet we now have an equation that has two things in it. Well, clearly x1, y1 is a point, and m is a slope, which is why we call this formula point slope formula. All right. By the way, we just did a proof, a coordinate proof, right? We started with a given that if you have a non-vertical line with slope of m and a point on the line x1, y1, that line is defined by what's in yellow there. We call it the point slope formula. All right, right now that's 13/8. Yes.
Technically, can't you, once you actually have the units for the point slope form, can't you take those and can't you simplify it into the slope?
You're going to see that here in a little bit. Yes.
Also, if you did that on the homework, is that acceptable?
Well, they're going to say they want it in the point slope.
What if I simplify?
But
it?
if you started with point slope and simplified it to
MS plus B.
slope intercept form, and the question said write it in slope intercept form, absolutely positively. That is a tried and true technique in algebra.
What about on the homework?
Yeah, but if they say they want you to write it in slope intercept or point slope, just leave it that way. You don't need to
Use
change
the
it.
form specified by your teacher.
And what did I say? Pick and choose for the last, what,
I'm
5?
talking about 11 through 16.
I forget what my instruction, I believe I said point slope for those.
Why? I already did it.
What? You were the, I threw
Should've
out the
paid
homework.
attention.
You
It was
saw it.
easier to simplify. Wasn't easier, but I didn't want to do it.
It wasn't actually easy.
I wanted to prove you.
It's actually a lot easier to do point slope form.
It is way easier to do point slope
Why did you do y equals mx plus b?
I can.
because you can. It is kind of neat the first time you see it. And I will show it to you in a few slides here if you haven't already done it. All right, does everybody have this copied down? This is called point slope. I don't know why our Algebra 1 book, most Algebra 1 books introduce algebra students to this formula. Our Algebra 1 book does not. I know I've talked about it occasionally, but I've never shown it to you formally. Now I have, and I proved it, by the way. So we can use it. So let's see how this works. We'll start off with stupid simple. Who wants the stupid simple one? Do it.
All right.
Point slope form.
So I gotta get, okay, so I have to do 7 minus.
I don't know, left to right.
Yeah, that is left to right.
It doesn't say y1, it says y. So y is y, x is x.
Okay, so y is still 7.
Yeah, no. Y you leave as y. You know, like in slope intercept form, you leave the y and the x alone.
All right.
You
so-
change the m and the b.
So y minus 7
Keep talking.
equals 3 times x minus.
Yeah, slope is not 3.
Oh, sorry, slope is 4.
So
Okay.
keep talking.
I'm trying to
So you
do that.
said y minus 7. Keep going.
So that's just 7y
Just y minus 7 is y minus 7.
equals 4 times, no, 5 equals 12 minus x.
You had it right the first time.
Oh, 4 times 3
4 times the quantity.
of 3 minus x 1.
You're close.
I don't, x my flip.
I'm just going to say this needs to be in front of your face while you're doing this. So do it again.
Okay, y minus 7 equals 4 times x minus 3.
See what happens when it's in front of your face? You get it right immediately. Now, what you were trying to do was take it out of point slope form. We can. This is what Ben could have Can I change this? You can. And then it's not point slope form anymore. This is point slope form. I do want to point out point slope form, both of these must be minuses. Okay. So if you were ever looking at this and you were trying to say, well, what's the slope? Well, the slope is 4, but what's the point? It's not -3, -7. It's 3, 7. Secondly, high school students get in a problem because it goes not X, Y, it goes Y, X. So occasionally that's the second big mistake. All right, Ben, you get the middle one.
Do I have to?
You do.
Okay, so first you gotta figure out this, because we just gonna say, okay, so what we're gonna do is so we know it's parallel, so we know it goes through the point -2, -5. We also know that's parallel to y equals 3x minus 4. Well, we already have the slope, it's 3x, you know, any line.
3x.
3.
3.
Because any line, because it's
Parallel to another line has the same slope.
Same slope. So we know the slope is 3. So now, because of that, all we do is.
Hold on.
No, keep it.
You're good.
Okay,
You're good.
so-
Now you're getting
so
in my
now
work.
we can start to write the.
So write the equation.
So we start with y minus, we look at y1, which is -5. So y minus -5, which is +5. So y plus 5 equals, now we put our slope, 3 parentheses, we put x, then we put minus at our x over here, which is -2, which we put -2, so +2. So the full thing is y plus 5 equals 3, comma, not
I
comma,
knew it.
parentheses, x
If it
plus
has a slope
2.
of,
All right.
Divide both
if it
sides
has
by
a slope
7.
of 3x, it's a quadratic.
But it's not. And that's
We actually have a different name for
So
that.
if it has a slope of 3x, it's 3x times x, which is 3x squared.
We actually have a different, well, we wouldn't use X though, but we have a different name for something. You will learn it in pre-calculus. All right.
What is it?
Do the last one.
3. Why? Me?
Yeah, last one.
Okay, so if it's
And
perpendicular.
I just want in yellow.
Okay.
I want no talk. I just want the answer.
Okay, give me a minute. So you want an endpoint slope?
I want in this point slope.
Okay, so y minus, no, so just y equals -3 times the quantity x minus 4.
Very good. Now, people will argue whether or not to write y minus 0, and the book occasionally does, and occasionally it doesn't. It's literally up to you. Now, most math books would say, why would you write y minus 0, right? You would just write y, right?
How do you get the 3 from?
What do we know about slopes that are perpendicular to each other?
They can
They are not equal to each other. They are
across from each other, never touching.
something. What do we know about the slopes of perpendicular lines?
They meet at one
It's
point.
from the start at, yes, and it forms a right angle. It was the start of the chapter. We made perpendicular slopes. I forget what section it was, but it was 1 or 2. Well, they're not the same. They are,
Different.
we had theorem, I don't know. Something about their products multiplied to get product is -1.
Yeah.
But to create one, we made we added something. We said their slopes are
Parallel.
opposite reciprocals.
Yeah.
Remember that?
Yes.
Yes.
Okay, so what's the opposite reciprocal to the slope?
-3.
Okay, that's where it came from.
Uh,
All right. Okay, more, are we okay with this? Because we've got about 5 minutes left. More or okay with this? Okay.
We're done.
No, we're not done.
No.
What am I giving you here?
Coordinates.
What am I giving you here?
Coordinates.
Coordinates.
2 points. Those 2 points are on a line. Okay, what are we gonna do?
Draw a line.
Well, really, first we can just figure out the slope.
We can figure out the slope.
We can figure out the point slope.
And then point slope, how many points do you need for point slope?
One, you can use either one of them.
Either
You can
one.
get the exact same answer
All right,
for both of them.
So slope, what's the slope?
The slope is 7 minus 2 over 3 minus 1.
Ooh, that's
which
nice.
equals, 4 over
5 over.
5. Yeah, 5 over 2.
Cool.
5 over 2 equals slope. Now we just take point slope.
Which one do you want?
Intersect. Let's do the first one. 'Cause that's
Let's do the
easier.
first one. Okay, go ahead.
So we have y minus 2 equals 5 over 2 parentheses x minus 1.
Okay. What if you pick the second one?
Don't.
Pick the second one, do it again.
Don't pick the
Y,
second.
y minus 7 equals 5 over 2 parentheses x minus 3.
So do you notice anything wrong here?
No.
No.
We're saying that both of these are,
Equal.
they certainly don't look that way. Look at that.
Because they're dudes different points, but they're both in the same line because they both.
They must be the same line. We better prove that.
No.
We don't have to prove it.
Let's
Do,
not.
do you agree that looking at this, you would say they're not the same line?
Yes.
No.
Let's prove it.
No.
All right. So what we have to do, which is what Ben was trying to do from the very start.
Type them into our calculator.
No,
Dang it. No.
you could, by the way. You just have to have it say y equals. Just add 2 to both sides, and you would say y equals. How are we going to prove that these are exactly the same? What was Ben trying to do that I said no to? And Jack was like, that sounds silly. Why would you do that? You're creating
Turn them into y intercept.
Turn them into y equals mx plus b. So what will we have to do?
Oh gosh. Well, first we're gonna add plus. Let's do the left one. We're gonna add plus to the other
Before you
side.
do that,
Oh. The parentheses. The
distributive property, right? So that would give me what? 5 over 2x minus 5 over 2?
Yeah.
It's going to seem like magic what I'm about to do.
And now plus 2, and that we
I got to have common denominator 2, so that would be 4 over 2 plus,
negative
minus.
minus 5 over 2, giving us 1 over 2. Therefore, y equals 5. Yeah. No, same thing on the side.
How about on this side?
Distributive property. Y equals negative 7 equals y minus 7 equals 5 over 2x minus 15 over 2.
Add 7 common denominator 2, so that would give me what? 14 over 2
Whoa,
minus 15 over 2, which gives me,
negative 1/2.
it's literally the same equation. The issue is that you won't even realize that you can suspect it. You can say, hey, look, parallel lines, same slopes. But you're not even going to know that you have literally the same equation unless you put it into y equals. Are you going to have to do that tonight for homework? No.
Yeah.
But I'm going to point out, and this was more of the Ben thing, which was you can change point slope to slope intercept pretty easy just by doing a little bit of distributive property. It does seem like magic. This is also why math teachers hate to grade this homework. Why?
Annoying.
There's 2 answers that are correct. If it says put it in a point slope, and I give you 2 points, I gotta do the problem twice in order to figure out what are the 2 right answers. So you know what math teachers typically do?
Don't care.
They'll give you 2 points, but they'll say put it into slope intercept form because then there's only 1 answer. But every single person, the easiest way to do that is this method right here. Right? There is another method of doing it. You learn it in Algebra 1, you've probably forgotten. If I give you 2 points, up, and it's how I taught you last year, but once you learn point slope, nobody uses that technique ever again. The technique is you calculate the slope, right? And then you solve for b. So we found out the slope was 5 over 2. So we write y equals mx plus b, where the slope is 5 over 2x plus b, and then we substitute one of those points in. This was last year's technique. Take 1 and 2 and throw that in there, and then solve for b. That method is not as, efficient or as elegant as what I'm showing you right here. Point slope is the way to go. These are the last 2.
No.
All right, they're both medium.
Oh wait. Well, if it's a vertical line, vertical means it's on the y.
A vertical line.
X-axis. So all we gotta do is if it's a vertical line, it's going through negative 3,2, it's going through 2, which means
So therefore, what's the formula?
x equals 2.
Wow, that was quick. Except it's negative 3. Why did you make that mistake?
Oh, because I'm an idiot.
So remember, on a vertical line, what never changes?
The vertical.
Of the values, what never changes? The x's or the y's?
The vertical in this.
It's the x value that doesn't change, which is why the formula doesn't say in form of y equals. It tells you in form of x, because you pick any point here. I don't know what that is, but let's say that's negative 3, 4. And this point right here is going to be negative 3, 2. And this point right here is going to be, negative 3, 0. What's not changing is the x value. All right, we got time for the last one.
Well, 2, x, y equals 2.
Yeah, why?
All right, now that you see that pattern, right? Okay,
No,
that was it.
I did
I
not
believe.
all existence of that process.
Yeah, that was it. Tomorrow we're gonna do big boy, big girl math, right?
Sir,
Tomorrow is gonna be the one that causes headaches.
yeah,
And this
What
one
is
was
that?
it's a written piece of paper containing the answer to that TED-Ed, whatever.
Oh, right. Well, you got 30 seconds. Go.
Okay, I'm gonna draw it.
Okay, can you give me 30 seconds and can you explain polar
No.
bonds to me?
Do polar, Jack. It's still an ordered pair.
Ah,
It's still an ordered pair, but one of those ordered pair is your degree measurement, and the other one is the radius.
what?
So if you think about x, y, how far left, right, how far up and down, polar is the same idea, except one is a degree measurement, and the second one is what's the radius. And that you can do the same basic idea.
Measurement for what? And what?
There you go. There's the answer.
Oh,
Look up here. So if you're right here, Jack,
Oh, yeah, homework.
3, 4, right? On a polar plot, right? It's the degree measurement. So let's say you're right here. So it's the degree measurement and the radius. So it's, I don't know what the degree. Now, polar, you typically use radians, not degrees, right? So the first one is, let's just say that's, 80 degrees. So it'll be 80 degrees, comma 2.
Also, Jake,
So where did he go?
I'm right here.
Oh. Thank you.
That's trying to be a little sneaky, but which one is our conversation about part of it?
Yes.
Hey, you want the homework?
oh, I have.
Oh,
Yeah, I got it. Do any box, I can put in paper. Homework for yesterday, I said that.
Oh,
No one's responsible. Video wasn't attached to it.
That desk, share this desk? No.
There should be 8 desks per count.
7.
So we are missing one. You did count the one way over there, though, right? It's the printer? 1, 2, no, this one belongs in the back. Okay, put it right there. I was trying to move things so I wouldn't have to constantly bump into this one, so.
Don't sit on the floor, it'll be fine. We could share it. We're gonna share a desk now. It's okay.